Hello dear students, hope you all are fine and eager to study today's lesson. So, stay tuned to me till the end of this lesson. Today we shall study lesson 2 of class 10th, acid, bases and salts. But before we begin with our lesson, I would like that all of you should recall a few important points that you have already studied in your previous classes. For this, I would like to ask a few simple questions to you, and answering these questions will bring your minds into action. So children, are you ready to answer these questions? Here is your first question. How do acids taste? Yes, all acids are sour in taste. Your next question. How do bases taste? Bases are bitter in taste. Your next question. What is the effect of bases on litmus paper? Yes children, bases turn red litmus to blue. Now children, tell me what will happen if the acids react with bases. Yes, your answer should be that when acids react with bases, they result in the formation of salt and water, and this reaction is called as neutralization reaction. So, now with refreshed minds, let us begin with the lesson acid, bases and salts. In today's lesson, we shall discuss about chemical properties of acids and bases. How do acids and bases react with metals? How do acids and bases react with each other? Reaction of metal oxides with acids and non-metallic oxides with bases. What happens to an acid or a base in a water solution? Importance of pH in everyday life. Some important chemicals from common salt. Children, let us start with the discussion on chemical properties of acids and bases. Fruits like orange, lemon and grapes are all sour in taste and are termed as citrus fruits. Such fruits are easily available at our home. We all are very much familiar with their taste. They are sour in taste because of the acid present in them. Some of the examples of other easily available household items that contain acids are vinegar, it contains acetic acid; tamarind, it contains tartaric acid; and tomatoes, they contain oxalic acid in them. Now we shall study about bases. These are the substances which are bitter in taste. Substances like soap, detergent and baking soda, which we use in our daily routine, are basic in nature. Children, do you know that it is not recommended to taste each and every substance? So, to identify whether a given substance is an acid or a base, we can use indicators. Some examples of indicators are litmus paper, phenolphthalein, and methyl orange. When we put blue litmus paper in an acidic solution, then the blue litmus paper changes to red. And if we put red litmus paper in a basic solution, then red litmus paper changes to blue. In this way, litmus paper can be used as an acid-base indicator. Similarly, we can use phenolphthalein also as an acid-base indicator. On putting a few drops of phenolphthalein in basic solution, it turns pink in color, whereas it turns colorless in acidic solutions. Methyl orange shows red color in acidic medium and yellow color in basic medium. Children, now we shall study how acids and bases react with metals. To understand this, let us perform an activity. Material that is required for the activity is dilute sulfuric acid, zinc granules, a test tube, and a test tube holder to hold this test tube, a delivery tube with cork fitted on one end, and a candle. Firstly, put a piece of zinc granule in the test tube. Then add 5 ml of dilute sulfuric acid in it. Now observe carefully. You will see bubble formation, and these bubbles are formed due to the evolution of hydrogen gas. To test this gas, bring the gas evolving from delivery tube near a burning candle. You will see that the gas burns with a pop sound. Let us hear to the pop sound once again. Burning of gas with a pop sound shows the presence of hydrogen gas. Have you observed, children, that in this reaction, along with hydrogen gas, zinc sulfate is also formed? So, we can summarize now that whenever a metal reacts with an acid, it displaces hydrogen from the acid, resulting in the formation of hydrogen gas, and in addition, metal salt is also formed. Children, observe another activity. To perform this activity, we require a delivery tube, calcium hydroxide, which is commonly called as lime water, dilute sulfuric acid, a test tube with test tube holder, a spatula, and sodium hydrogen carbonate. Firstly, take small amount of sodium hydrogen carbonate in a test tube. Then take about 2 ml of dilute hydrochloric acid to add in the test tube and to mix with sodium hydrogen carbonate. But before this, put one end of the delivery tube in the beaker containing calcium hydroxide. Now put hydrochloric acid in the test tube containing sodium hydrogen carbonate. You will see some effervescence in the test tube as soon as the hydrochloric acid mixes with sodium hydrogen carbonate. This is due to a chemical reaction in which a gas is evolved. Children, carefully observe and you will see that a gas is passing through the delivery tube into the beaker containing calcium hydroxide. Whenever hydrochloric acid and sodium hydrogen carbonate react, then sodium chloride, water and a gas is formed, and this gas is carbon dioxide. The evolved carbon dioxide gas, when passed through lime water, turns this lime water milky. Lime water turns milky due to the formation of a chemical compound which is white in color, and the compound is called calcium carbonate. Here, calcium hydroxide combines with carbon dioxide to form calcium carbonate and water. So children, here you can clearly see for yourself that lime water has turned milky. We can now summarize that whenever metal carbonate or metal hydrogen carbonate reacts with an acid, then metal salt, carbon dioxide and water are formed. When excess of carbon dioxide is passed through calcium carbonate, then calcium hydrogen carbonate is formed, which is soluble in water. We will now see how acids and bases react with each other. Acids and bases show variable chemical properties, but have you ever wondered, children, what will happen if an acid is mixed with a base? Acid reacts with the base to produce salt and water, and this reaction is called neutralization reaction. In general, neutralization reaction can be written as acid plus base gives salt plus water. For better understanding of neutralization reaction, let us perform this activity. Take 5 ml of dilute sodium hydroxide, which is also called caustic soda, in a beaker. Add a few drops of phenolphthalein indicator in it and stir with the help of a glass rod. What changes do you find in the color of the solution? Yes, the solution has turned pink because sodium hydroxide is basic in nature. Now, with the help of a dropper, add a few drops of dilute hydrochloric acid in this solution and stir again. Do you find any change in the color of the solution? We see that the pink color of the solution is fading away. Add a few more drops of acid and stir again till the solution becomes colorless. See, the solution has now turned colorless. This indicates that acids and bases when mixed together, nullify the effect of each other. As a result of which, the solution is now neither acidic nor basic in nature, and now it has only salt and water in it. This process is called neutralization. Children, let us now understand the reaction of acids with metal oxides and bases with non-metal oxides. First of all, reaction of acids with metal oxides or with metal hydroxides. In general, whenever an acid reacts with a metal oxide or with metal hydroxide, it results in the formation of salt and water. Let us try to understand this with the help of an example. Say, for example, if we react hydrochloric acid with any metal oxide or metal hydroxide, then chloride salt of that metal and water are formed. This will become more clear if I give you an example of a metal oxide also. So, if we react dilute hydrochloric acid with copper oxide, then copper chloride and water are formed. We can represent this chemical reaction by chemical equation as 2HCl plus CuO, that is copper oxide, gives us CuCl2, that is copper chloride, plus H2O or water. Now, if we replace copper oxide with potassium hydroxide in the above reaction, then potassium chloride and water will be formed. The chemical equation for which will be HCl, that is hydrochloric acid, plus KOH, potassium hydroxide, will give KCl, that is potassium chloride, plus H2O, that is water. Take another example, and in this, instead of dilute hydrochloric acid, we will take dilute sulfuric acid. So, if we react dilute sulfuric acid with copper oxide, then we will get copper sulfate and water. Here, copper sulfate is sulfate salt of copper. Chemical equation for this reaction will be H2SO4 plus CuO, copper oxide, gives us CuSO4, that is copper sulfate, plus H2O, that is water. And if dilute sulfuric acid is reacted with potassium hydroxide, then potassium sulfate and water are formed. And the chemical equation for this reaction can be written as H2SO4 plus 2KOH gives K2SO4 plus 2H2O. Children, similarly, if nitric acid reacts with metal oxide or with metal hydroxide, then metal nitrate and water are formed. For example, if nitric acid is made to react with magnesium oxide, then magnesium nitrate and water are formed. In the same way, if nitric acid is made to react with calcium hydroxide, then calcium salt, that is calcium nitrate, and water are formed. Reaction of base with non-metallic oxides. Children, we have already studied that how carbon dioxide reacts with calcium hydroxide to form calcium carbonate and water. In this reaction, calcium hydroxide is a base. It reacts with a non-metal oxide, which is carbon dioxide in this case, to form salt, that is calcium carbonate and water. Children, if you remember neutralization reaction, then I would like you to recall that in this reaction, an acid reacts with a base to form salt and water in a manner very much similar to the reaction of an acid with metal oxide and base with non-metal oxide. So, if we compare the neutralization reaction and the reaction of base with non-metal oxide, we conclude that non-metal oxides are acidic in nature, as non-metal oxides react with base to form salt and water. Children, now is the time to study that what do all acids and bases have in common. All acids have similar chemical properties due to the presence of hydrogen ions in them. These hydrogen ions are represented as H positive. Acids produce hydrogen ions in the presence of water, or you can say that acids produce hydrogen ions only in their aqueous solutions. Similarly, all bases produce hydroxide ions in the presence of water or in their aqueous solutions. The hydroxide ion is represented as OH negative. Hydrochloric acid dissociates in the presence of water to give hydrogen ions. These hydrogen ions cannot exist alone, but they exist after combining with water molecule as hydronium ion. This hydronium ion is represented as H3O positive. Acids give hydronium ion or hydrogen ion in water. Bases give hydroxide ion in water. Bases which are soluble in water are called alkalis. Mixing an acid or base with water results in decrease in the concentration of hydrogen or hydroxide ion per unit volume. This process is called dilution, and the acid or the base is said to be diluted. The process of dissolving an acid or a base in water is a highly exothermic process. Concentrated acids like concentrated nitric acid, concentrated sulfuric acid, or concentrated hydrochloric acid should be mixed with water very carefully. Never add water to a concentrated acid because in doing so, a lot of heat is generated, which may cause the mixture to splash out and cause burns. The excess heat generated can even cause the glass container to break. Let us now try to understand how strong are acid or basic solutions. Children, to find out how strong a given acid or a base is, we use pH scale. This pH scale is developed for measuring hydrogen ion concentration in a solution. The P in the pH stands for potence, a German word meaning power. On the pH scale, we can measure pH values ranging from 0 to 14. pH is simply a number which indicates the acidic or basic nature of a solution. Higher the hydronium ion concentration, lower is the pH value. The pH of a neutral solution is 7. If the pH value of a solution is less than 7, then it is acidic in nature, and if the pH value increases from 7 to 14, then it represents an increase in hydroxide ion concentration in the solution, which means basic character is increasing. The strength of acid and base depends on the number of hydrogen ions and hydroxide ions produced respectively. Acids that produce more hydrogen ions are called strong acids, whereas which give less hydrogen ions are said to be weak acids. Similarly, bases that produce more hydroxide ions are called strong bases, whereas which give less hydroxide ions are said to be weak bases. Now, let us study about the importance of pH in everyday life. First of all, we will talk about the importance of pH value in human body. Our body can work properly within a narrow pH range of 7 to 7.8. When pH of rainwater is less than 5.6, it is termed as acid rain. When this acid rain flows into the river, it lowers the pH of river water, posing a great threat to the aquatic life. Children, it is very interesting to note that our stomach produces hydrochloric acid for proper digestion of the food that we eat. But during indigestion, our stomach produces too much acid. This causes pain and irritation. To get a relief from this pain, it is recommended to use antacids. These antacids neutralize the excess acid. Magnesium hydroxide, also called milk of magnesia, a mild base, is often used for this purpose. Tooth decay starts when pH of the mouth is lower than 5.5. Children, do you know that tooth enamel is made up of calcium phosphate, and it is the hardest substance in our body. It does not dissolve in water but corrodes when the pH in the mouth is below 5.5. The best way to prevent this is to clean mouth after eating food. Using toothpaste, which are generally basic, can neutralize the excess acid produced by bacteria in the mouth and thus can prevent tooth decay. Now, let us study some more about salts in this part of the lesson. Common salt, sea salt. Common salt. The salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is the salt that we daily use in our food. So, it is called common salt. Common salt as a raw material for many chemical compounds. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salt are also found in several parts of the world. These large crystals are often brown due to the impurities and are called rock salt. The common salt thus obtained from the seawater is an important raw material for various materials of daily use such as sodium hydroxide, baking soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. First of all, carefully look at this reaction. NaOH, that is sodium hydroxide, plus HCl, that is hydrochloric acid, gives NaCl, sodium chloride, plus H2O, that is water. This reaction shows how sodium chloride, also called common salt, is prepared from sodium hydroxide and hydrochloric acid. This is a neutral salt with pH value 7. Common salt is also used as a preservative for food items. Children, it should be very clear in your minds that common salt is not only used in our kitchens for making food, but it is also used in various industries as a raw material for making many chemical compounds. First such compound is sodium hydroxide. Sodium hydroxide is also known as caustic soda. Let us see how sodium hydroxide is prepared. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. In this process, chlorine gas is given off at the anode and hydrogen gas at the cathode, along with the formation of sodium hydroxide near the cathode. This process by which sodium hydroxide is prepared is called chlor-alkali process. All the three products produced in this process are very useful. Hydrogen gas produced is used as a fuel for making ammonia and for welding purposes. Sodium hydroxide is used in degreasing metals, making soaps and detergents, and for making artificial fibers. The chlorine gas produced in this process is used as a disinfectant for water treatment and in cleaning swimming pools. At the same time, it is also used for making bleaching powder. Now, let us see how bleaching powder is prepared. Bleaching powder is produced by the action of chlorine on calcium hydroxide. The chemical name of bleaching powder is calcium oxychloride and its chemical formula is CaOCl2. Preparation of bleaching powder can be represented in the chemical equation form as CaOH whole twice plus Cl2 gives CaOCl2, that is calcium oxychloride or bleaching powder, plus H2O. Let us now discuss about the uses of bleaching powder. It is used for bleaching cotton and linen in textile industry. It is also used as an oxidizing agent in many chemical industries. And lastly, it is also used for disinfecting drinking water to make it germ-free. Now we will discuss how baking soda is formed. Chemical name of baking soda is sodium hydrogen carbonate and chemical formula is NaHCO3. The main raw material required for making baking soda is sodium chloride. Preparation of baking soda can be represented in the form of chemical equation as NaCl plus H2O plus CO2 plus NH3, which is also called ammonia, gives us NH4Cl, that is ammonium chloride, plus NaHCO3, that is sodium hydrogen carbonate. Uses of baking soda. It is used for making baking powder, which is prepared by mixing baking soda and a mild acid such as tartaric acid. Sodium hydrogen carbonate, being alkaline in nature, is also an ingredient in antacids. It is also used in soda acid fire extinguishers. Next compound that we will discuss is washing soda. Let us study about the preparation of washing soda. Chemical name of washing soda is sodium carbonate decahydrate and its chemical formula is Na2CO3.10H2O. Another chemical that can be obtained from sodium chloride is washing soda. If we heat baking soda, it forms sodium carbonate and recrystallization of this sodium carbonate helps in the formation of washing soda. Preparation of washing soda can be represented in chemical equation form as Na2CO3 plus 10H2O gives Na2CO3.10H2O, that is sodium carbonate decahydrate or washing soda. Children, let us discuss about the uses of washing soda. It is used in glass, soap and paper industry. It is also used in manufacturing of sodium compounds such as borax. It can be used as a cleansing agent for domestic purposes. And lastly, it is used for removing permanent hardness of water. We will now study about the crystals of salt. Children, you must have seen the crystals of copper sulfate in your science labs. They are blue in color. These blue-colored crystals of copper sulfate appear dry to you. But are they really dry? To find an answer to this question, let us perform an activity. First of all, take some crystals of copper sulfate in a test tube and heat them. As I told you earlier also, that copper sulfate crystals are blue in color. But did you notice, children, that on heating, These blue crystals have turned white. Isn't it amazing, children? Can you see some water droplets in the test tube? Seeing these water droplets, are you not compelled to think that where have these water droplets come from? Because we had taken dry crystals of copper sulfate. For the time being, I am leaving your questions unanswered because the next step of the activity will clarify all your doubts. Now, add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. You observe once again very amazing results. That is, copper sulfate restores its blue color. Children, let me now explain all this to you. Copper sulfate crystals, which appeared dry to you, actually contained water of crystallization. When we heated the crystals, this water was removed and was visible to all of us on the test tube. Removal of water molecules from the crystals of copper sulfate turned blue crystals to white. This fixed number of water molecules present in one formula unit of a salt is called water of crystallization. 5 water molecules are present in one formula unit of copper sulfate. Chemical formula of hydrated copper sulfate is CuSO4.5H2O, where 5H2O represents 5 molecules of water of crystallization. Gypsum is another salt which has water of crystallization attached to it. It has 2 water molecules as water of crystallization. It has the formula CaSO4.2H2O. Now we shall study about the preparation of plaster of Paris. On heating gypsum at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate. This is called plaster of Paris. The chemical formula of plaster of Paris is CaSO4.2H2O. Plaster of Paris is a white colored powder which, on mixing with water, changes back to gypsum. The chemical equation for this is CaSO4.2H2O plus 1.5H2O gives CaSO4.2H2O, which is gypsum. Now, let us discuss about the uses of plaster of Paris. Doctors use plaster of Paris for supporting fractured bones in the right position. It is also used for making toys, materials for decoration, and for making surfaces smooth. Now is the time for a quick revision of what we have learned in this lesson. Acid-base indicators are used to indicate the presence of acids and bases. pH scale is used to find how strong an acid or a base is. When an acid reacts with any metal, hydrogen gas is evolved along with the formation of metal salt. pH of a neutral solution is 7. pH of an acidic solution is less than 7, whereas it is more than 7 for a basic solution. Dilution of a concentrated acid is a highly exothermic process. Children, now is the time to test your knowledge. So, are you all ready, children? I will ask you a few questions related to the topics we have covered in this lesson, and you have to be quick in thinking the answers for them. So, here is your first question. Which color do we get on adding phenolphthalein indicator in a basic solution? Yes, you should be very quick in answering this question. And the correct answer is pink color. Your second question is, which gas is liberated when metals react with acids? The correct answer is hydrogen gas. Third question, what does a pH scale represent? The pH scale represents the strength of acids and bases. Your next question, what are the byproducts of chloralkali process? The correct answer is sodium hydroxide, hydrogen gas, and chlorine gas. And here is your last question. What is the chemical formula of plaster of Paris? Yes, children, if you have given the answer as CaSO4.12H2O, then you are absolutely correct. With this, we come to the end of the lesson. Hope you enjoyed learning the lesson with me, and I also hope that you were able to answer all the questions asked in the revision section correctly. But even if, children, some of your answers were incorrect, there is nothing to worry about. What you have to do is that after watching this video, read the lesson from your books. This will help you to complete the lesson thoroughly and give you a better understanding of today's topic. Thank you.